Hello, everybody. Welcome. If you can hear me, put your name in the chat, please. Please put your name in the chat if you can hear me. Please put your name in the chat if you can hear me. If you can hear me, please put your name in the chat. Please put your name in the chat if you can hear me. Okay, I see Antonisha. I see Kimelo. I see Seth, Aki. Who else is there? Where are the others? Oh, okay, I see you, Tata. Hi. Okay, good. Uriratala, I can see you. Give us 1 second and we start. We start in 1 minute. Just give me 1 minute and we are starting. We're starting, everybody. Okay, so everybody, we are. Let me make sure everybody's in. Just give me 1 more second. Is there anyone else? Let me say, please put your name in the chat if you're live with us right now. Honestly, who else is there? I can see Tatayoni. I see you there. Uratile, Uriratile as well. Aki. I see Seth. I see Kimelo. I see Antonisha. That's good. Where are the others? Give me 1 second. and we get started. Okay, let's get started. So we are going to start our series through organic chemistry now, and I'm going to be going with you daily through chemistry lessons, and we are going to see how it goes. We are going to be going through organic chemistry, and I'll be giving you questions for each of the things that I teach you, and then I want you people to give me the solutions. Give me my assignment, and you make sure you submit, and we'll be. That's how it's going to be. I'm happy because this is a way you can always refer back to this. If you want to always check back and confirm something, you can always come back to the videos and watch. Are we together? So this is going to be amazing. I hope you're all ready. I'll be sending you the links every time I go live for you, and you can be able to join. Okay, I can see you, Eric. Well done. I see Eric there. I see Rorisa. Everybody, if you're in make sure you put your name in the chat if you're present. We'll check again at the end. Now let's get to work. So remember that so we're going to be doing our series chapter by chapter and doing questions, right? Our chemistry has 12 topics. Our IGCSE chemistry, Cambridge IGCSE chemistry has 12 topics, and we got to know all 12. So here I'm doing topic number 11 out of 12. And topic number 11 out of 12 is going to be organic chemistry. Right, okay? Topic number 11 out of 12 is going to be organic chemistry. I hope you're all ready. Okay, so what we are going to start with is, I know that most of the times you have to start with crude oil and how you distillate it and get all these families and stuff, but I'm going to be going with you through the thing. So here is how organic chemistry is. Okay, I'm going to give you a summary. This is something which is so important for you to have an idea of the whole thing that you are about to do. Okay, Hwaba, I see you, and Paida, well done. So when you want to know, when you want to do organic chemistry, let me say this. Organic chemistry is the study of carbon. Okay, I don't want to over explain things because it will take our time. So organic chemistry is the study of carbon and its compounds. So we are going to be studying an important guy called carbon. And we are going to be studying the things that come from carbon. We want to study carbon, then we're going to study all the things that come from him. Okay? All the families that come from him. So let's talk about how it is. Here is how organic chemistry works. Organic chemistry works like this. There's a guy called carbon. Now, you are going to split the things that you need to know about this into 3 so that everything makes sense. Okay, you can split it into 4, you can split it into 5, but here's your organic chem, right? You'll be doing organic chem. You'll be studying carbon. Okay? Carbon and its families, right? So let me just say organic chem. Okay, you have to know it like this. You're going to have to know one branch, which is going to be naming and drawing structures. Naming and drawing structures. Okay? Naming and drawing structures of all the families that you have to know. Right? So, the 5 families. Okay? You do 5 families and a little extras. We have to know how to name them. Each thing, you must see a structure and know its name. See a structure and know its name. See a structure and know. I don't care where it came from. I don't care what reaction happened or whatever. That's irrelevant. The most important thing is that you know how to name. You have to know how to name. So the very first thing is naming. So when you're starting naming, remember what I'm giving you is important cheat codes that make work light for us, because we don't want to be just doing everything. All the information, trying to put it in our heads one time. No, that won't work. So we are going to do naming. Then after we do naming, we are going to look at reactions. The reactions of each thing. Reactions and conditions. Reactions and their conditions. Then the last section, we are going to talk about 2 things. Number 1, polymerization. And then number 2, you say some theory. Theory means this is where we are going to talk about some small things, nitty-gritties. Nitty-gritties. Huh? Okay, some small things, some nitty-gritties. Naming and drawing structures. This is where you do isomerism. Isomerism is in here, is in naming and drawing, because you'll be needing to know what are isomers and all these things. So it's going to be coming in there. Right. This is going to be our organic chem. This is how we're going to study carbon. So we're going to talk about all the families and we see how we name them. Then we just need to do questions where we are naming together. Okay, we need to do question after question where we are naming. We don't care where it came from. We should be able to look at something and name it, or to see the name and draw it. That one we should be good. Then now we can start to look at other things. So first of all, it's just naming. Guys, it's naming. Right. Let's talk about that first part, naming. So we're going to look at first part, naming and drawing. Let's talk about how we name and we draw structures. Naming and drawing. Talk about all the families, okay? Okay, all the families. So basically, let me just put a little bit of, something that you do much in organic chem theory, but I'm just going to put a little bit so that you can be able to understand what is going on. Okay? I want you to know a little bit of theory. Are you ready? All right. So what you must know is that we have things that we call, number one, homologous series. And then we have something that we are going to call functional group. These are the two most important things. So let me explain. Are you ready? When we are studying organic chem, we're going to study it like we're studying human beings. So let's say you've been given a big job to study. There's this thing called a human being. We want you to look into it for us, okay? Can you look into human beings and study how they work, a lot of things about human beings? So that's your main job. We're giving you a job, and your job is going to be taking a look into human beings. That's like carbon. So you're looking at organic chemistry, which means you are looking at carbon, and you look at them like you look at human beings. Right. What do we know about human beings? We know that when you study human beings in general, you're going to start to see that, we have different families. Okay, you start looking at, you say, what is your name? They'll tell you the name, and then they'll tell you their surname. You'll be like, oh, okay, surname. You hear another name, and you hear a surname. So there's going to be something called families, and families will be grouping people together. People from one family, people from this family, people from this family, people from whatever family. Okay, any family that you can think of. So we have different families. We also have different families in organic chem. So when we are going to study organic chem, we are going to know that, you should know that everything we are studying will have carbon inside it. So carbon is the main guy here. With carbon that we are not going to talk about, carbon dioxide and the carbonates. Anything with carbon, we are going to talk about it. Okay? So we're going to talk about here. What you should know is that everything with carbon, they actually have groups. You can group the things with carbon. Really? Yes. How will you group them? You'll be using their DNA. Just like when you are grouping families of human beings, you use their DNA. Oh, this is this family. Oh, this is this family. Oh, this is this family. What are you using to say that? You are using their DNA. You're going to look. When you see two people, how do you prove that they're from the same family? DNA. So that's what we're going to be doing. In organic chem, you should know what we mean by homologous series. Homologous series is family. So when we say, please tell us all the homologous series, we're saying, please tell us all the families that are there. Please tell us all the families, and you only have to know 5 for IGCSE, right? There are more than 5, obviously you know that, but this is IGCSE level. We are getting higher and higher and higher and higher and higher. So let's start with it. Oh, Aki, I see you. Hi, welcome. So a homologous series is a family of compounds. When you say, oh, these two are in the same homologous series, you're saying they're in the same family. So a homologous series, hey, we are doing chapter 12 back to chapter 1. I know that. We're starting from back to front. So you'll be like, oh, I want to start from chapter 1. Don't worry about it. Whatever we start with, okay? These chapters stand different from each other. Just make sure in that chapter you know everything you're supposed to know for that particular chapter. You'll be fine. You'll be fine. Homologous series is a family of compounds. Okay, I want you to say a family of organic compounds that have, right first, that have similar features and similar chemical properties due to them having the same functional group. What is functional group? Functional group is the same as saying DNA. So if you say they have the same functional group, you're saying these two things have the same DNA. So homologous series it's a family of organic compounds. We'll see the alkane homologous series means the alkane family, the alkene homologous series, the alcohol homologous series, the carboxylic acid homologous series, the ester homologous series. Yes, these are homologous series. These are families. These are the families we have in organic chem, period. And we know each family will have similar, they'll behave in the same way. When you talk about the reactions they do, it's because they have the same DNA. Come on now. And DNA in chem is a part of them that if you look, you see them having. Okay, so let's write that. Functional group. And this is the part which makes them behave in the way they behave. Are we together? So functional group is a group of atoms that influences. So say a group of atoms. Okay, responsible. You can say group of atoms bonded, which are bonded in a specific way or specific arrangement that is responsible for the reactions, chemical properties of a family. So that is responsible for the, I want you to say, for the chemical properties of each homologous series. So alcohol family all behaves in a certain way because, oh, highly lengthy. Alcohol family all behaves in a certain way because they have the same functional group. Come on now, guys, don't let me down. Functional group will determine how something will behave, and members of the same family will have the same functional group, period. Okay, now this is it. So we have number 1, homologous series, number 2, functional group. So let's see the homologous series, okay? Let's see the homologous series that we must know, and let's see their functional groups, their DNA, something that we will use to identify, to say, once we see that, we know your family, okay? There's something that we'll be looking at. Remember, we are looking inside somebody. We are looking inside. Something that once we see the arrangement, we are like, this guy. Oh, this one. So that is what you have. So homologous series, it means the family. We have the 5 homologous series. There are 5 of them that we must know. Then their functional group. And then we'll start to see how we name things. So functional group. Okay, functional group. Then let's see the ending. Remember that the family that you're from is going to determine your surname. Your surname is going to be based on which family are you from. So we are working on naming. That is why I gave you these 2 definitions. I want you to understand naming. Naming depends on the family, and family in chem is called homologous series. So the homologous series will determine your last name. So I want you to say the suffix. Okay? Okay, the suffix. And you can say here, ending of the name. Suffix means the ending. Ending of the names. So all the guys from a certain family should all have a name that ends in the same way. That makes it very easy to name, guys. All you have to identify is the families. Identify the family, the homologous series, then you can know the name. So let's see the homologous series. Number 1, we have the alkane family. We have the alkane homologous. I'm not going to do too much. I'm just going to do a little bit of naming. I give you questions. I see how far you guys can go. Homologous series is with alkane. So it's going to look like this. This is what it looks like. You'll be just seeing single bonds between carbons and hydrogens like that. There is no double bond, nothing. Okay, so it's going to be just single bonds. Single bonds, carbon and carbon and hydrogen throughout the whole thing. This is going to be an alkane, okay? That's going to be an alkane, and it should end with ane, butane, propane, ethane, hexane, heptane. Everything should be ane. The last part of your name should be ane. You are an alkane. Come on now. You're an alkane. So the last part of your name ends with ane. It's done. Are we together? Now we go on. The second family, okay? The second family is the alkene. I want you to know 5. So let's quickly do it. It's the alkene family, and you can see it by just having a double bond between carbons. Once you see this, I don't even want to discuss with anyone. This is an alkene. That's the only family which has this. This is the DNA of the alkene family. Anything like this is an alkene. I don't want to discuss anything. I've told you, don't change. So how does the name end? The name will end with E-N-E. So when it comes to naming, don't you let me down. Now the third family is going to be the alcohol family. The alcohol family, their name, what will they have? What will the alcohol family have? They will have a C and an OH. Okay? Something, they will have something, some other things there. We don't care what they have. But at the end, they will have a C with an OH. Once you see an OH, once you see an OH, Mr. Man, that is an alcohol. That is an alcohol, straight up. So this is going to be an alcohol. That's the alcohol family. Yes, all of them end with COH. Yes, sir. All of them. Okay? Do you hear me? And they end with ano. Okay? They end with ano, the ending of the name. Now let's do the last two, the 4 and the 5. 4 is going to be the family called carboxylic acid. So now you know the families of carbons, eh? You know the types of carbons. So carbons that we have, when you look at a carbon, either it should be a carboxylic acid, or it should be an alcohol, or it should be an alkene. We should look at it and know who is this one now. Then we look at another one, we should know who is this one now. We look at another one, we should say who is this one now. We should know his family. So this one, how does the carboxylic acid end? It's going to be COOH, okay? And let me show you how it's going to look like. It'll be like this. It'll be a C, then it goes a double bond to O, then it is an OH like this. So this is going to be what it kind of like, okay? You can say it ends like this. Once you see like this, this is going to be a carboxylic acid. 2O. Yeah, that's a carboxylic. Okay, that's a carboxylic acid. Yes, so it ends with anoic acid. It ends with anoic acid. Can you all see this? Can you all see this? Put reactions, put thumbs up, put things like that. Come on, guys. You know. Now we have the 5th and final one. Okay, put things like this. Yeah, things like that. You should be putting those. Now let's see. Now we're going to have number 5. The last one is the ester. Okay, this is the last one. The ester. The perfumes, things that smell nice, are from our organic compounds. They have carbon in them. Are you telling me? Yep, I'm telling you, my friend. They are esters. They are esters. What do you know about it? An ester, look at what it's going to do. It's going to have a carbon, and the carbon is going to be bonded to some oxygens like that, and then an oxygen, then it goes to a carbon like that. So there's going to be COO, then it goes, yes, it continues, yeah, like that. So there's going to be, so when you write, it's going to be like COO, like C, then it goes like this. This is going to be an ester like that. Okay? And when you see it, this one ends with anoic acid, ethanoic acid, propanoic acid. That is for carboxylic acids. For ester, it will be something io, then you say anoate. So you can say propanoate. Let me say something ill, then you say dash dash dash, then you say something anoate. Okay, something anoate. So it's going to be dash 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 ill, dash 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 anoate. So something is coming here, something is coming here. So you're going to have 2 parts: propyl propanoate, propyl ethanoate, ethyl butanoate, or whatever. That is going to be an ester. When you see those things, it is going to be an ester, and that these are esters. Okay. Okay. You hear me, guys? Say yes in the chat if you can hear me. you can understand me so far, say yes in the chat. Yes, there is a triple bond, but you don't do it at IG level. You will never see it like that. Okay, good. I can see a lot of you understanding. That's great, great, great. Say yes if you can understand. If you can understand, say yes. So these are the families, and we now know their name. Their name will come from their family, period. You can't break away from that. Now let's put the last part, something that I want you guys to now have about naming. Okay? Well done, well done, well done, well done. Now let's put something that I need you to know, then you can try to name, right? Right. Let's talk about the prefixes. Let's now say prefix. Let's say the first part of naming, of names. The first part of names. Remember, this is now the prefix. We've talked about the last part of names. Last part of names came from the family that somebody is in. So that is why we needed to know the families. You can't know the last part without knowing the family, because the last part comes from the family. So the family is the one that determines his last part. But now we are talking about the first part of the name. The first part of the name is going to come from what? The first part of the name is going to come from the longest carbon chain. Okay? So, first part of the name. The first part of the names of organic compounds comes from the stem. Okay, you can say the number of carbons, of carbon atoms in the longest continuous carbon chain. The first part comes from the number of carbons in the longest continuous carbon chain. Okay? The longest continuous carbon chain. How many carbons can you move through? Let's say I do this, for example. If I do this and I do this and I do this, I put an O and I do this and I do this and I do this and I do this. If you look here, I should move, and as I move, I should be just moving through carbons only, okay? You can't touch anything that's not carbon. So if I move like this, it will be carbon, oxygen, so I have to stop. So that means here, the chain here has 2 carbons, okay? Then I can look at the other chain on the other side of it. I'm going to see carbon. Oh, 4 carbons. So here it has 4 carbons. So that means the name of this guy is going to come from here, his first name. Then we'll talk about this part somewhere else, okay? But the name is going to be on the longest continuous chain. And the longest continuous chain, even if they put it like this, okay? If then they put it like this, to say a carbon, then another carbon, then another carbon, then a carbon going down, then a carbon going down, like this. So even if you put another, the longest chain we can see, we move like this, then like this, then like this. This is the longest chain. This is the longest continuous chain. It will have 1, 2, 3, 4, 5, 6. So you should count how many there are. So you can see the longest chain has 6 carbons. So that means we are going, its name is going to come from these 6 carbons. Oh, Theo, I see. Hi. Okay, so the name will come from the, always look how many can you move through without jumping. The first name will come through the carbons, the biggest number. So you will check, you have to check. There's no other way. You have to check and see how many carbons can you go through, okay? Now let's see what names you get when you have 1 carbon, 2 carbons in the chain, okay? So you're going to look at how many carbons you have in the chain, then you are going to choose the name from this list. Let's put let's put the list here. I want you to say here, number of carbon atoms in the longest chain. Number of carbon atoms in the longest chain. Then here on the other side, I want you to now put the first name. First part of the name. First part of the name. The surname will be from what family you are from. We know that. We're going to put the last part. The last part will be from what family. The first part will be how many carbons do you have? Like, tell us when you move through continuously without lifting your hand or your pencil. How many carbons are you moving through? Then you can choose a name from here. When there is one carbon, your first name should start with meth. Okay? Don't ever choose any other. You'll be wrong. If there's only one carbon on that whatever thing you're looking at, if let's say something has one carbon and it is an alkane, it will be methane, because all the alkanes end with ANE, right? ANE. So if you have one carbon and you are an alkane, it will be methane. You understand? If you have one carbon and you're an alcohol, it will be methanol. So it will be methanol. Okay, you understand? So this is how it works. You'll always look at the number of carbons. You count all the carbons that you can see that are in a continuous chain. In a continuous chain. We're going to practice, of course. This one is it. You say it, then you're going to put whatever else that comes for 2. So meth, it. 3, you say prop. So you have to practice this. Okay? You have to. This is the naming. You need to practice this. Prop. Then 4, you say bute. When you see 4, it's bute. Prop 3, bute 4. So when you see bute in your name, we know that whatever you had 4 carbons in the longest chain. Okay, in the longest chain, there were 4 carbons. Then when there are 5 carbons, you're going to say pent. Then you finish. Pentanol, pentanoic acid, whatever, pentane, pentene. We don't care whether it's an alkene or what. We'll see. We'll look at the functional group. We'll look for the functional groups. Somebody can't hear me. Oh, hear me? Hear me? People, can you hear me? If you can hear me, please say yes, I can hear you in the chat. If you can hear me, please say yes, I can hear you in the chat. Can you hear me, guys? Okay, great. Well done. I'm proud. So for 5, you say pent. For 3, you say prop. 1, myth. 2, eat. So you have to be practicing so that you remember. 1 is myth. 2 is eat. 3 is prop. 4 is bute for 4 carbons. Bute for 4 carbons. Okay, Antonisha, I see that. Okay, no problem. Bute is 4 carbons. 5, I'll say pent. Then I'll finish off with the family. I'll look for what family. When I see 6 carbons, I'm going to say hex. When I see 6 carbons, I'm going to say hex. When I see 6 carbons, I'll say hex. When I see 6 carbons, I'm going to say hex. When I see 7 carbons, I'm going to say hept. Okay, we should know all the way up to 10. When I see 7, it's hept. 6, it's hex. 7 is hept. Hept comes after hex. Hex for 6, hept for 7. Okay, when I see 7 carbons, I'm going to say hept. When I see 8 carbons, I'm going to say oct. Oct, then it finishes. If it's an alkane, it will be octane. If it's an alkene, it will be octene. If it's an alcohol, it will be octanol. Okay, the last part is from the family. The first part is from the number of carbons. So there are 2 things I should always look for when I want to know the name. First, I should look for how many carbons can I move through continuously without raising my pencil. Then that's going to be the first part of the name. Then the last part of the name, I should look at which family or homologous series is he from. And how do I know? I look at the functional group. I look at that guy and I look at Who is there? Okay. Oh, it says my audio is breaking. Is my audio breaking? Click on settings, Pida. Click on settings, right? And choose 480p or something on quality. Reduce it a little bit so that you can be fine. So when it's 8, it's oct. When it's 9, this is the last. We are done. When it's 9, it's non. So it's going to start with non, then end with something else. It's going to start with non, then end with something else. When it's got 10, it will be dec, then end with something else. When it's got 10, it will be dec, then end with something else. So 1 carbon, meth. 2 carbons, eth. 3 carbons, prop. 4 carbons, but. The first name will be but, the first part of the name, okay? It's gonna be but. In here, the name is written continuously. First name and surname are joined to be one thing, but the first part will be but. Then it will end with whatever family it's from. Butano or butene or butane or butanoic acid, we'll see, okay, because our carboxylic acids end with anoic acid, so it'll be butanoic acid, propanoic acid, methanoic acid, ethanoic acid, ethanoic acid, propanoic acid, butanoic acid. You'll be looking at the longest chain. So 10 is dec for 10 things. 9 is non for 9, oct for 8. That's how it goes. Don't let me down now. Don't you let me down. You can do this. Trust me. Come on now. You can do this. So this is going to be it for it. Let's do some questions. There is no learning, which is learning when there are no questions done. Right. Let us do some questions. Right. Name the following compounds. Number 1, you see something like this. Don't worry about hydrogens and whatever. I'll explain them to you later. We are not yet doing formulas here, okay? I don't care whether you understand the formula. I don't even care, okay? I don't care whether you understand the formula or not. I just want you to know the name. So let's talk about the name of this guy. It has nothing to do with you understanding the formula. The name is the name. We know that the name number 1, we are going to look at which group is that. Okay, which homologous series, okay? Then number 2, we start by looking at how many carbons are in the longest carbon chain. So let's look how many carbons are in the longest carbon chain of this animal. This is an animal. How many carbons are in the longest carbon chain? 1, 2, 3. Oh, 3 carbons. So this is going to be prop. Then we look for which family is this guy from? Which family is he from? We see this carbon to carbon double bond. Carbon to carbon double bond, we know that it's found in only one family. It's the alkene family. You can go and look here to see. We said when you see a carbon to carbon double bond, it is an alkene. So the alkene family, yes. And how do the names end? In. So the first part was prop because it was 3. For 3, you can go and look here and you see it's prop for 3. So we started with prop, then it's an alkene, so it will be prop in. Alkenes end with in. So this is propene. That is the name of that guy. That guy is called propene. Right, let's do number 2. 1, 2. I don't care just look at the carbons, okay? Look at the carbons. 3, 4, 5. Put 5 like that. There we go. What is the name of this guy? So propene is him. This guy, what is the first part? Look at the longest continuous carbon chain. I can move 1, 2, 3, 4, 5. 5 of them, 5 carbons. Yes, I went through 5 carbons. So it starts with pent. Then what family is this? If it was just carbons and hydrogens and carbons and hydrogens and carbons and hydrogens and carbons with no double bond or anything, then it would have been an alkane. But I'm going to see an OH. I'm like, there's an OH here. Which family is known for having an OH only? Just an OH. Here it is. It is the alcohol family. It is the one which just has a C bonded to an OH. That's the alcohol family. And how do the names end? They end with ano. So we go to that. We say pent for 5. Okay, 5 you can come and see here that it's pent. You've seen here that it's pent. Then you go down and you saw that it's from the alcohol. So you come and say pent ano. Okay, because alcohols end with ano. So this becomes pent ano. That's the name of this guy. The name of this guy is pentanol. Right, so I'm going to give you a bunch of structures that you must name. Okay, I'm just going to and I'm going to put them in the group, and I want all of you to answer and send me my work. I want my work. Okay, you try to send it tonight so that I can go through it whilst you're sleeping. Goodbye. Thank you. That's it for the organic chem lesson day 1. We'll meet again for the next chem lesson where we continue with organic chem.